I had the wrong screen up. Hi, everybody. How you doing? Welcome to the virtual night sky. Welcome to our version of the virtual night sky for September the 7th, 2022. Last 2 weeks ago, right, I sort of introduced that we were starting school. Students were back, and certainly it is in full force now. And we're very excited to have a great semester and over 100 incoming freshmen to the class of the School of Earth and Space Exploration of all of our various majors. I think it's really, really super cool. And so it's a bit busy time of year. Everybody's getting adjusted. We're doing a lot of stuff. And so tonight we're kind of coming to you with a show. We're a little bit road weary from getting our school started and everything, but we're going to have a great time. Let me introduce myself and my team. My name is Rick Alling. I'm the manager of community outreach for the School of Earth and Space Exploration at Arizona State University. Our headquarters is on the Tempe campus. We operate out of a building called ISTB-4, and that building includes gallery spaces that you can come visit, and it also has this very special theater, the Marston Exploration Theater. And so a lot of the inspiration for this virtual show, for those of you that have been following for a long time, actually comes from that. We do programming for the public, all ages of public, in the Marston Exploration Theater. And we're looking forward to having people back. And at the end of the program tonight, or towards the end of the program tonight, I'm going to announce a very special show that you can come to. We've got a Saturday coming up in the middle of October. More about that later. But Earth and Space Exploration Day is a time for you to come see us and see what we do in our building and in our place. I'll mention that again later. On our team, very much the regulars we always have. Back from Florida is Kim Baptista with us tonight. And at the later in the show also, I'm going to ask her to give us a little update on what she was doing in Florida and what it was like. And she's getting some updates on a mission, or not updates on a mission, depending how you look at it. She was there to see the Artemis 1 launch. And as you probably already know, because you watch the news, that launch has been delayed. And Kim can kind of tell us about what that's like to be there when that happens. The other thing, other people on board here, Meg Hufford, she's with us. She's a partner of mine. She and I have been working the sort of school shows and the community outreach and the visitations of the center for many, many years. And so she's with us tonight to kind of help hold things together. Alicia Hyatt is our education specialist, and you'll see her a little bit later. She's going to get us up to date on Europa and some science with Europa and why that's important. Also, students Alex Blanche and Armin Dalla. Armin is also going to take a little part of the update for a mission to go sort of image and do spectroscopy on the moon of Europa. The main part of the show, and we're going to get to this in a minute, I'll just introduce it and then do some more housekeeping. The main part of the show is I want to just kind of celebrate a little bit of amateur astronomy. And amateur astronomy is just sort of things you can see with a small telescope. Things that don't necessarily appear or resolve very well in our night sky, but things with a little bit of help, binoculars, a little bit of telescope, some things. And I'm calling them fuzzy objects, fuzzballs in the sky. And I'll give you a whole load of a bit of history about what they are, how we came to know them, some personalities along the way. And that's really where we're going to focus our show. Your night sky, but some of those things are a little bit harder to see. Some of those things you need a little help to see, and how fascinating they are and historic as well. So we are in a webinar format, and that means we don't chat. You can't do that with this particular Zoom, but you can communicate with us, certainly. And so at the bottom of your screen is a little button that says question and answer. You could take that seriously and ask a question anytime along the way, and we encourage you to do that. Or you can also just give comments if you wanted to sort of like say, this happened and I did this, or I've seen this before, or that kind of thing, just to sort of like give us a sense that you're watching and that you're here. And so freely use the question and answer button to not only make comments, but also ask questions. And if there's any young people, what we usually do for school age youngsters, if you wouldn't mind, if you want to ask a question, I encourage you to do that. Just use your first name and not your last name, just your first name and maybe the grade you're in, and just sort of, ask your question from there. Working in the background, the team is sort of fielding those questions and answering them on the fly, using that opportunity to communicate back to you. And then sometimes we bring those questions to the floor. We'll sort of have periods during the program where the questions sort of appear. And so that's kind of how we do this. We do closed captioning. And it's up to you to turn it on or off on your machine. It makes it easier for us to upload these recordings to the web, and then they're sort of automatically closed caption for us. So that helps us, and so we do that, and it's a service to those that need it. And if you don't want it, you can just basically exit out of your machine. You don't have to have it there. There's a little X button next to the closed caption. So it won't turn you off. It'll just turn the closed captioning off. So with that, sort of exciting times and all that stuff, I'm just going to introduce you to an astronomer of the past, somebody that's been around for a long time. A lot of amateur astronomers are going to know this guy. I'm going to sort of just put his picture up here. This gentleman is called Charles Messier. He's a Frenchman. He was born in 1720s or 30s, 1730, I think it was, in a small town in France. He grew up to be an astronomer, and eventually he worked for the Paris Observatory under Delisle. And Delisle was a famous map maker and astronomer of the day, hired Messier to be an astronomer at the observatory, but he actually worked mostly out of a place called the Cluny Hotel, or the Hotel Cluny. And so if you've ever visited Paris, that's now a milestone. It's a visitable place. It's a museum of its own. And anyway, so within the grounds of that particular hotel, Charles Messier had a telescope, and he was assigned to be an observer. He was supposed to observe things in the night sky and just describe what he saw. He also came to this job, and he was passionate about hunting for comets. And comets were really popular back in the day. So when he was doing his observing from about 1771 into the 1780s and that kind of stuff, that was sort of the span of his early career. His goal was to sweep through the sky, identify things that might be comets, and then sort of discover comets. And at the end of the day, he actually did discover about 10 by himself and an 11th with another person that sort of co-claimed the comet. So that really worked. But if you remember, here's another little piece of history. Edmund Halley was an astronomer, and Edmund Halley looks through records and predicted the return of a marvelous comet that appears every 74 years, approximately. They didn't know the timing. They just knew that this was a major comet and that it would come back. And so astronomers like Charles Messier, they were looking for that. They predicted the return, and they were ready to sort of see this comet return, and sort of like, they wanted to be the astronomer to do it. They were just trying to pin down that long period and when it comes back. And you guys know it today. Halley's Comet is one of the most famous comets there is. But this was the excitement of the time, right? Telescope technology was enough that they could kind of sweep through the sky and they could identify things that were non-stellar objects. And comets, when you look at them with a telescope, they just look like a little fuzzball. That's it, just a little fuzzy patch in the sky. It takes a more sophisticated telescope than Charles had. Long telescope technology would have to grow quite a little bit before they can actually sort of resolve comet, nucleus, tail, some of the things that we see today. But comets were of interest, and they appear in his telescope as a little fuzzball. So the way to discover a comet is to sweep through the sky, be very, very careful, be very, very rigorous. And when you see a little fuzzy thing, you have to note exactly where it is, and then look at it every night for several nights, or every week for several weeks. If it moves against the background of stars, bingo, you've got a comet. If it doesn't move, then it's just a fuzzball in space. So here's the cool part. What he did is he sort of, let me see. I'm going to get another little image up here. This will sort of give you a little sense of what he did. And this is really a fascinating piece of history. And so let me spend a little time with this guy. So Messier was looking for comets, but every once in a while he would be frustrated because he saw something that looked like a fuzzball, and it took him several nights, if not weeks, to figure out it wasn't a comet. So he had this great idea to create a catalog of objects that were fuzzy, that could look like comets, but weren't comets. And then he could share that with the whole astronomy community, and they would all know, okay, here's an object, don't bother, it's not a comet, it's something else. And so with this, he developed a catalog. In his lifetime, he delivered about 103 objects. We call it the Messier Catalog. And amateur astronomers still use it today to identify objects in the night sky that are telescope viewable. And so in this particular image, I've shared just a couple of these with you. So all of these would have appeared to Messier in his telescope as just a little fuzzy object in the sky. You can see we can resolve these much, much better today, right? Because we have much better telescope technology. And these are the iconic images. These are the ones that we see. And many of them, after he stopped doing this, they added about 6 more. So then there was 109, a dispute out of 110th, but we think it's the same as something else. So we sort of credit the catalog of being M1 through M110, and all of them are now known to be a variety of objects. In a minute, I'm going to kind of just take you to your night sky, and we're going to identify a couple of these little fuzz balls, how we can see them from here, but also what maybe Charles Messier was seeing with his telescope and what it looked like in the night sky. I just love the irony here, and I'm going to sort of point this out if it's not clear to you already. This particular catalog is the most revered catalog in amateur astronomy today. There are people that go out once a year in March. You can actually work through an entire night and see every object in the Messier catalog. You can see all of them, right? But you have to be really systematic. You got to know exactly where to go, which one to watch first, because they'll set, and then ones will rise later. You can do that. It's amazing. But the irony is this was a catalog of objects that he didn't want to find. This is a catalog of objects that was distracting him from his search for comets. And now it has become one of the most famous night sky, deep sky object catalogs that has ever been. Messier also was a very, very good observer of his own. I've got another image here I wanted to show you. Here it is. Let me just open this up a little bit so you see it a little bit bigger. This is actually a Messier object. I'm going to show you. It is M42. We know it as the Great Orion Nebula. And so in his catalog, the way he built it is the first, say 45, 46, 48 objects are things that were very well known. He didn't discover these things, but he identified them, he described them, and he put them in the catalog. So 1 through about 46 is just stuff that has been known for a long time. But he was a great observer, and he also added to our knowledge several of these nebulas and clusters and globular clusters and things like that over time. So he really built a library of his own, always sort of focused on discovering the things that weren't comets, because that was his passion. That's what he wanted to see. So, but you can see the detail, right? Remember, in this time, this is history. This is 1775, about when this particular drawing was made. We didn't have cameras back then, right? The astronomer actually was somebody that went out at night, wore a jacket, had his servants bring him hot tea all night, and they would look at these objects and they would literally just, painstakingly sketch out the aperture of the telescope, but also what's going on inside, and as much detail as they possibly could. Of course, nowadays we know this particular object as being one of the most famous and iconic images in telescope history. It's a birthplace of stars. It's well known. It's just below the belt in Orion, in a dark sky. You can actually sort of see it. It does look like a little fuzzy area that's hard to resolve. So that's Charles Messier, and that was his purpose, and that was what he did. And it was sort of in the age of the amazing sort of French astronomers of the late 18th and the early 19th century. And it was really amazing. I'm just going to show you sort of where Messier is today. He is actually buried. This is his tomb. Oops, I didn't open it right for you guys to see. Hang on a second. There it is. This is his tomb. It's in Paris, and you can sort of find it. There's also a plaque at his hometown where he's been. So he is known, he is revered, and he's one of the panoply of amazing astronomers that came out of France in that particular time period. All right, I'm going to switch over to my little sort of planetarium program. You guys have seen me use this before. So we're just thinking now. I hope my Pencil is organized, and here we go. So I think you guys have seen this sort of when I've used it before. Just for a minute, I'm going to find those constellation names confusing. So I just wanted to show you. Let me see. I'm going to go to, this is tonight. Let's just go to exactly right after the show tonight. I'm going to flip forward really quickly to 8 o'clock. So as soon as we close up, you can go outside. You know, you've noticed, I think, that it has been a little bit clearer, that there's not as many clouds in the sky. We have this amazing little heat wave coming and going, but you know, part of that is because of the dry sky. That's sort of like this. Last week, you remember we talked a lot about the Milky Way galaxy, or 2 weeks ago. That was the feature of our show. And tonight, I'm just going to kind of just show you around some things that are going on, some things that are in your sky, and some things that we can see. You can see that basically, let me get back again a little bit, just to remind everybody, everything that is green in this image is essentially below the horizon. That's stuff that is not visible. And if you had a really good view of the entire horizon all the way around you, you'd be able to see everything in this picture. The Milky Way is tracing right across the top of the sky. Now, we've had this conversation many, many times before. It's not easy to see the Milky Way from the big city and the city lights and with Phoenix. And you really do have to get away a little bit. And really, without apology, tonight's show is going to be about stars that you can see, constellations that we can recognize, but also things that really need a dark sky or a little help, a little bit of optics to help you sort of see. So we're going to do that. Notice that right at 8 o'clock, this is kind of cool. Jupiter is just rising. So I think I've been kind of warning you over time, the latter part of this year, now for the rest of September, October, November, December, all the way into January, Jupiter is going to be a really prominent object in our night sky. Earlier in the year, we were showing you how that's a morning object. Now, right, this is how things work. The Earth is going around, and the planets that used to be morning objects 6 months ago are now evening objects, and that's kind of that's the way it works. Neptune is not very far away. You would have to have a really nice telescope to see Neptune, but it does show up in that little fun blue color there. That's Luna. She's doing her little barky thing. Things going on. Oh, we have irrigation in our neighborhood today, so you'll probably hear Luna bark of the irrigation man. Saturn is also up, and notice it's a lot higher above the horizon. Don't go try to, well, actually tonight is a good night to go find Saturn, because look at its position right next to the moon. So you will see the moon is just above the southeast horizon at 8 o'clock. When we finish our show, you can go out and find that. It's a waxing gibbous moon, as we call that. So it's past half, it's growing. It's going to be a full moon this Saturday. So if you're one that sort of likes to keep track of such things, you just give it like Wednesday, Thursday, Friday, Saturday. It's going to grow. It's basically between its quarter and its full phase now, so it's sort of becoming a gibbous. I took an image of the moon the other night, and at the end of the show, I'm going to show it to you because I really sort of like the way it turned out, and I'm proud of it. So I'm going to show it to you, everybody. Anyway, so wouldn't this be a great night to go out right after the show, check out where the moon is, and then just up and a little bit to the left, you're going to find the planet Saturn. These, both Jupiter and Saturn, are great objects for a small telescope. If you've been wondering when to get out your hobby telescope and when to sort of like get it, dust it off and try to see some of the stuff, this is a really good time to do that, because you can actually see the rings around Saturn and you can actually see the Jovian moons. The Jovian moons, Io, Europa, Ganymede, and Callisto are going to come up again at the end of the show, because we're going to give you a little update on a mission to Europa, one of Jupiter's moons. Okay, that's that part. Now let me sort of just pick out the brightest stars in the sky. I'm going to organize my things so that I'm this way. Let me find. I'm going to look towards the north here. I'm going to sort of change my view just a little bit. And I'm going to show you some stuff going on here. You've seen this before if you've been watching the show. I have this little sort of ability, it sort of takes a little chunky to draw on the screen here. So I'm just going to kind of point out, bink, 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 bink. This is the little asterism we call the Big Dipper. I can sort of fill it in a little bit. Doesn't that look like a sort of little dipper pole with its handle right there? It's 7 stars. And The two N stars over this way, if you remember, we sort of like go over this all the time, point to the North Star. So this is Polaris, the North Star, the Pole Star. It might be the most important star in your sky. It's not the brightest, not by any means, but it's important because it marks directly to your north. And then opposite that, if you sort of like go the other direction, I'm going to go in this way a little bit, you see this sort of W in the sky, bink, 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 these stars. This is actually the constellation known as Cassiopeia. I'm going to just sort of make that a little bit bigger so you can see. And if I fill in this stuff a little bit, and sort of put legs on this thing, sort of that kind of stuff. And I see a little queen sort of here with her crown and sort of her little arms sticking out, and her little legs and feeties on the bedside chair. It sort of looks like, maybe it doesn't look like, it's a queen, Queen Cassiopeia, and she's sitting on her throne. And so ancient mariners used to call it the Queen's Throne. They didn't call it Cassiopeia. The constellation is called Cassiopeia, but it actually is sort of, if you fill in the W, if you make it work like that, it looks like she's almost upside down. She's going to slip out of her chair, doesn't it? Anyway, those are the features of the north part of the sky. And this is a chance to see both of those constellations together, because what happens is during time, right, 6 hours from now, the Dipper will be below the horizon, right at the north. This is scrape and just almost set, almost not set. Some of the stars will set, some of them will just scrape across the horizon, and Cassiopeia will be very high in the sky. The same thing happens 3 months from now. When you go out at 8 o'clock, you're going to see that same image I just described. So we've got this thing doing a 24-hour clock, but also a 12-month year. And they just rotate around each other and around each other continuously. And so this is a great time to go out and take a look at them, okay? Let me sort of get rid of this little screen for a moment, because I've got to show you another feature. I'm just moving over so we can sort of see towards the west. You've definitely seen me do this before, so I'm just going to kind of just get my screen ready again. I'm going to repeat the process. Here's the Big Dipper, and here's the handle of the Dipper over here, 1, 2, 3 stars. If you just follow those stars in this direction, you come to the fourth brightest star in the entire night sky, and the brightest star in your sky tonight. The star is called Arcturus, and it's the anchor star, the alpha star of a constellation called Boötes. And Boötes is sort of standing here. I might be able to draw him a little bit. He's got one arm just sort of like stretched over his head and a club up here. His head's going to be kind of up this way. His other arm is kind of holding out like a little sort of a plant in front of him. We've kind of talked about the history of that before. Boötes is a great constellation to follow, because he is the son of Demeter, and he's also the inventor of the plow. And so it really, really relates to agriculture. And so the fact is that over the next several weeks, you're going to see Boötes every evening. Will just sink a little bit further into the west until he disappears completely. And that is about the time of year that we harvest our crops. We bring things in. The planting season is over. Agriculture is over for the year. We go into that period of fall and then the freeze. Boötes will reappear again in the spring in the eastern sky, and then just every day just get a little bit higher in the sky. And so from about March or April, when we can see him, he'll cross over the whole sort of sky and then end up over here and then start to set again. So it's a really, really good summer constellation to get to know and to watch and to see how that works. Okay, now the story today though is about Messier objects, and I'm going to show you two today, just so you can sort of like keep track. I'm going to get my screen organized, at least especially so I know what I'm looking for. And then we'll do this. You've seen this before too. These three stars right here. Oops, better, I'm going to get a little closer. And I'm going to do the screen thing again. So these three stars right here, this one called Deneb, this one called Altair, and this one called Vega, make this really wonderful summer triangle. It's an isosceles triangle. You remember your geometry? And that's still prominent, still high in the sky. And when we had that conversation last week about the Milky Way, we sort of remembered that this is actually a swan. big, huge wings coming out this way and that way. The tail of the swan is over here, and the long, beautiful neck of the graceful swan goes up this way to a little star out here called Alberia, and the whole thing follows the line of the Milky Way as if it's flying south, as if it's getting ready for winter to come and sort of like sending itself down to the south. What a beautiful constellation that is. I'm going to erase all this because I got to show you something else. Up here in the constellation that surrounds Vega, it is in here. This is, first I'll sort of draw the constellation. This star right here, oops, let me sort of turn my pencil back on. This little star right here is called Vega. And the constellation that it anchors is called Lyre. And so Lyre is a harp. It's not somebody that doesn't tell the truth, it's a harp. And if sort of see sort of an ancient harp thing, I can draw it this way. And so we'll like give it a little bit of shape here. It probably has a little bar right here and another one up here and strings coming across. You sort of see how that works. You've sort of seen these before. You take one of those, you pick it up and you stroke it, and you can sort of make beautiful music. The lyre is actually sort of has a really great story of its own, but I'm not going to go there. I actually want to show you something else. I'm going to point to you to one of the Messier objects, M51. It is right between these two N stars. So if you sort of think of the big bright star is Vega, and there's this sort of funny little, what do they call this? A parallelogram. It's a rectangle that doesn't have exactly straight sides, a parallel. Between these two stars at the end over here is a little object right there. And very, very difficult to see with the unaided eye. I mean, you have to have really, really super dark skies, but really in a dark sky with binoculars or something like that, you'll definitely see a little sort of fuzz ball. I'm going to mark it one more time right here. And then I'm going to go find it on our main screen here. So if I zoom in on, here's Lyre again. So here's the little parallelogram, and here's the object we're searching for. We're going to call that the Ring Nebula. Center object. I'm going to zoom in on it. Here we go. We're on our way. There you go. As we get a much, much better view. Look what's going on there. One of Charles Messier's objects, one of his fuzz balls, one of these little fuzzy pieces in the sky, catalog number M51, Messier 51, is what we now call the Ring Nebula. This is a really cool object because it's a planetary nebula. I might be able to get a little bit more zoom on it. And you can see that in the middle is a little sort of dot. That's a remnant star. So this was a star that was probably just a little bit bigger than our sun when it was alive, when it was doing its thing. But what planetary nebulas are, the name is really bad because they're not planets and they're not really nebulas. But anyway, what they do is when a star like our sun exhausts all of its fuel, so our star is burning hydrogen, turning it into helium, as it sort of runs out of hydrogen and starts becoming just mostly helium, it loses some of its energy and the star starts to shrink, right? That power inside, that fusion reaction is keeping the shape of the star and keeping it really large. And so it starts to shrink a little bit. And then as it shrinks, it reheats, it gets more dense and hotter in the middle, and then it'll start fusing the helium atoms into heavier things like carbons and then later oxygens and those kind of things, creating ever heavier elements as it goes through these pulsations. But every time it shrinks a little bit, its outer shell gases spurt out, go out into space. They just basically move off. They leave the star itself and expand into space, being pushed by that stellar radiation from this remnant star. And then every single time it does that, another set of gases sort of like off gas. And so what it makes is this big, kind of big, gigantic spherical cloud with the remnant star eventually runs out of all of its energy and all of its ability to recharge and fuse. And it shrinks into this little thing we call a white dwarf, almost a cinder of a former star. still very hot, still giving off some radiation, but what it leaves in its place is this beautiful ring, sort of the notion of the star in the middle of it, and that's it. And so here it is in your night sky, in the constellation of Lyre, one of the ancient Greek constellations with a big story itself, later discovered by Charles Messier as a fuzzball that wasn't a comet, and named it M51. And that's one of those objects you can go see. I just think that's really, really cool history, and it's a great sort of place to sort of take our conversation. I'm also going to show you, let me see, I've got to get my bearings straight here because I got to be in exactly the right place. Over in towards the west of that area. So let me just draw this for you. Hang on just a second. So here's the constellation we were just talking about. There's Vega and there's the Ring Nebula. If I go just from there, almost directly towards the west in this particular direction, I'm going to head this way. There's another constellation over here. I'm just also sort of like outline it for you. It kind of looks like this. This is part of it over here. And you can sort of see what this is becoming is the constellation Hercules. And this little area right here that I've drawn is also known as the keystone, right? You know, a keystone is a rock that is shaped as a piece of masonry shaped in just the right shape to be the top stone in an arch. So they call it the keystone, and that's kind of cool. I love this pretty good constellation too because it's kind of fun. It's fun to see, and Hercules is out there sort of head to head with Abiuscus, which is another constellation I like. But what I'm going to do is, here's the keystone again. This way, this way, this way, and this way. And right between these two stars, this is pointing towards the west, if you want to sort of do orientation, about 1/3 away from that star and about 2/3 away from this star is a little fuzzball. This one is definitely visible by the naked eye. And we have record of people way back in history sort of seeing this particular star and understanding sort of that it was something special and all that stuff. It made, in fact, it is so bright and so well known that when Messier got to it, it was one of his first 40 that he cataloged because it was a known object. He called it M13. Let me just show you what that looks like. It's a totally different kind of object, but as I sort of like, if I zoom in here a little bit, there's the object. See where I sort of said it was going to be between those two stars, about 1/3 of the way over. I'm going to kind of light it up. They're going to call it the Hercules Cluster. I'm going to call it M13. Let me center it and let me go out there. And do you think this is going to look like a planetary nebula, like the Ring Nebula? No, it's something totally different. In this particular case, the star shows as a really, really wonderful, we call this kind of object a globular cluster. And in there are thousands and thousands of stars and really compactly sort of kept gravitationally attracted to each other. The cool thing about globular clusters is they kind of hover around our galaxy. They're above the top of it, they're below the bottom of it. They kind of like, almost like if you see our galaxy in the plane of our galaxy, they almost look like little bees or something like flying around. They're also very ancient. These stars are really, really, really old. They were sort of part of the first stars that were even born in our galaxy. They were part of the original galactic material that created stars. And so there you go. Here it goes again, an object that we can find at night. This is a really, really cool object with a telescope, because from binoculars to a small telescope to a medium telescope to a really good telescope, you just resolve more and more and more stars. But it shows as a group of stars as opposed to a little fuzzy dot, and even the smallest of telescopes. So I just sort of love the fact that these things are here. It's this time of year that you can go out and find these particular objects, and I think it's really great. I'm going to try to show you, I'm just running a little bit on time because, as you know me, right? We sort of like, I like to talk. And I'm going to just switch over the view here a little bit. I want to kind of get you way out. I'm using that other program. Remember a couple of weeks ago, we were kind of talking a lot about the galaxy and had a really wonderful guest. Dr. Karen Nierman was with me. We were talking about some of the stories of the galaxy. Let me get out of here. Let me just get way, way, way. There goes our sun. There goes our solar system. We're on our way. We're on a little bit of a journey because of some catalog, another catalog I want to show you when we get out here. Okay, way out, way, way out. Okay, here we go. Let me just roll over here a little bit so you can see the full force of our galaxy. Look how far away we are. So what Charles Messier, oops, way too far. Okay, what Charles Messier could not possibly have known is that where these objects were. He could see them as fuzzballs, and he could see that they were stationary. He could then catalog. He could tell that they weren't comets, and that was kind of his thing. So, why not just give up on these things? I'm going to just sort of remember we sort of showed you this. That little blue dot is where we live. Okay, now I'm going to do this. I'm going to light up what we know as all of the planetary nebula. Remember the ring nebula, right? Nowadays, look at all these. This is our half of the galaxy. We're in the middle of that little thing. And each one of these dots represents a planetary nebula, a little cloud of gas that was built by an exploding or expiring star. My story about our sun eventually, as it sort of off gases, reduces, its energy starts to dissipate. It starts to burn heavier and heavier elements until it just sort of crunches down into a little cinder. Each one of these objects is a planetary nebula. So if we look hard enough, we could find that one. We could find M51. That particular ring nebula is going to be one of these little white dots in the sky. Messier couldn't have known that. He wouldn't have known that. I'm going to turn those off. And then what was the other thing we saw? We were looking at globular clusters, weren't we? And remember I said that they kind of hover around our galaxy almost like bees. So here's where known galaxy globular clusters are. And if I get a little closer, I think the screen might be close enough to see. Oh, see that one in the lower left over there? You see that? It says M4. Now you know what the M stands for. That particular globular cluster, a little cluster of stars that we can find in the night sky, was discovered or named by or labeled by Charles Messier in his famous catalog. M4 is just one of those objects that he has. All right, so tonight we have discovered a little bit of history. We have discovered a little bit of sort of what happens when you have some technology. You can look just a little bit deeper in the night sky. The range of sort of objects that are part of that catalog, all of that kind of stuff. Let me just sort of bring one of those images back up. Was it this one? Oops, nope, not that one. That one I'm going to show you a little bit later. Not that one. Oh, it's this one. So you can see here on the screen, just to the left of Charles Messier, that's that ring nebula. And then several of these images are of some of those globular clusters that he had. And so anyway, this is sort of a memory and tilting our hat to Charles Messier, a pioneer in discovering the night sky, labeling, documenting, creating a catalog that we still celebrate and use today to sort of find our way as amateurs around the night sky. And it's really, really wonderful to, that he did this and we have that legacy. All right, I'm going to kind of stop this part of the show. We're going to turn things over to a little bit of Q&A. And I think we got some polls for you. So I'm going to kind of just stop talking for a little bit and let somebody ever take over and let us know what we're talking about. We've got a couple polls here. What's this about?
Yes, I've just launched our poll. The first question, where are you viewing from? We want to know. And our second question, before tonight, had you heard of Charles Messier? I know that name is really common in our building, but is it common where you're from? And then our third question, have you ever attended an in-person event at our Tempe campus? We'd love to know if you've been there before, and if not, I think we're going to talk about an opportunity to come and visit shortly. So make sure you cast your votes, and I'm going to turn it over to, I believe, Alex to take over the Q&A for us.
I sure can. Yeah, so we have a great question from Pam. She's been asking about Voyager, if it's still transmitting, but she had a great question. You mentioned the Voyager spacecraft. Are they even still in the solar system? Have they left?
Left, gone. Yeah. So the Voyager spacecraft, you remember they were launched in the 70s. I guess you might have to check the math. I think it was 78. And Voyagers 1 and 2 are twin spacecraft. They both had a similar mission. They were going to fly out using that sort of drafting technology where they sort of get a gravity assist from planets just to get them moving and get them out into the outer part of the solar system. Oh, one of them went on past Jupiter and Saturn and on to Uranus and Neptune. The other went past Jupiter, Saturn, and then sort of like took off up into the sky. Voyager 2, ironically, was launched before Voyager 1, but both of them sort of are out there. And yes, they've left the solar system. And this happened about, I don't know, the big announcement was probably about 4 or 5 years ago. And scientists projected that they were at this place called a Heliopause. And that is a place in space where the radiation from the sun diminishes as you get further and further away from the sun. And the radiation from basically interstellar matter and the stuff that's kind of out in space starts to take over. And so, and then communicating, yes, the reason we know that is that there's instruments on both of those objects, both of those spacecraft, and they're still transmitting after all these years. So somebody do the math, 78 to 22, isn't that about 45 years that they've been traveling through space? Do I have that about right? And that's really amazing. And they did an amazing job of teaching us about our outer part of the solar system. And then they just keep going, and really super cool. So I'm glad you asked that question because it's a really fascinating story. There they go. All right. Anything else, Alex? Got another one?
We kind of just got a question from Jasmine, actually, about globular clusters and gravity and where that gravity comes from. What's the source of the gravity holding all these stars together?
Oh, interesting. Well, so mass has gravity by itself, right? So gravity is just one of the four forces in nature, and the more massive something is, the more gravity it has. So if we think of, we sometimes compare it to weight, right? So, say you have a little dog, like a little toy poodle, it's not going to weigh as much as a big Great Dane, right? Great Dane, more massive, poodle smaller, but their weight difference is reference to the gravity of the Earth pulling them down. Same thing happens in space. Any object, whether it's a planet or a little asteroid or a little tiny thing or a spacecraft or a sun or something giant like a super black hole, whatever size, it's going to have a measurable mass. The mass is going to determine the amount of gravity it has. So in a globular cluster, each one of the stars has its own gravity. So as they're born, a lot of times we see what's called open clusters. So stars are forming, but they also sort of are forming in a region that is expanding, and they sort of just are automatically born to sort of expand and push themselves across, and they get very diffuse. And so they have this original sort of energy. In the case of globular clusters, they're sort of just born in a region of space, and they just kind of hug each other. They stay kind of close to each other. They're sort of the gravitational pull of each star is pulling against each other's star, and they maintain that really, really tight kind of ball-like structure. So anyway, that's kind of the answer. Gravity goes with mass. The mass of the stars bring its own gravity, and that's what attracts them to each other.
All just kind of stuck together for eternity. That's all the questions we have, so I'll turn it back to Alicia to share our poll results and then get back to the rest of the program.
Thank you so much, Alex. 80 of us responded. Thank you so much. Number one, where are you viewing from? 45% of us are from the Phoenix metro area, so in our own backyard. That's awesome.
Sounds about right. Yep.
And then 33% of us, the second largest group, are just from the United States, all over here. So that's awesome. And then we have 4% that are outside of the US. I just thought that was fun to announce. Before tonight.
It might be the parents of somebody that's on the team. I don't know. It could be. So
it could be. It's a high probability. But before tonight, had you heard of Charles Messier? 60% of us had. That's wonderful. That's wonderful to hear. So last but certainly not least, have you ever attended an in-person event at our Tempe campus? 63% of us said no, so we'd love to get you out there. And 38% of us said yes, and we'd love to see you back. So thank you for filling out the poll, and I will turn it back over to Rick.
Thank you. And yes, at the end of the show, we'll sort of give you a little bit of sense of something, the next thing you can come see and come visit us. It's coming up in the middle of October, so that'll be really cool. Thank you, Alicia. Those were good choices. And did anybody get hung up with the idea that if I'm in Phoenix, I'm also in Arizona and I'm also in the United States? Oh, well, I guess I think people got it. So that's pretty good. All right. The next thing we wanted to do is actually I was going to kind of use the Skyscan system again. If you don't mind, let me go back there. And I'm going to show you something else. I wanted to sort of introduce you to Jupiter, and it's in the night sky, so you probably can see that. Let me see, how do I do this? You might have noticed that we are way out there, so it's going to take me just a little bit to get home. I've got to get this right. I've got to get this up. I'm going to turn this on. I'm going to center the machine here on the sun, and then I'm going to just sort of fly home really, really quickly. Here we come. That big blue sphere there is in our system. We call that a radiosphere, and that's how far radio waves have traveled away from the Earth, right into space as we come in. I can turn it off now. Boom, boom, boom. We don't need it anymore. It's not a guide anymore. As we get a little closer, boom, 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 here's the sun. And we probably should see some of our planets sort of start to appear in the sky. There they are. And I'm going to turn some orbits on so everybody can kind of see the solar system like we usually see it. We've got 4 inner rocky planets. We've got 4 outer gas giants. That question about Voyager sort of like comes into context now. Can you imagine how long it took to actually sort of get it off the Earth and out to its first target? Was Jupiter. I just learned today. I went to a lecture today, and I learned that one of the Voyagers actually went past an asteroid on its way and imaged for the first time an asteroid called Ida. And Ida is a special asteroid. And sorry, this is a tangent, but it has a little tiny baby asteroid. Ida is kind of looks like a potato. And there's this little tiny thing called Dactyl. And so Ida and Dactyl are up there. Let me just switch our view to Jupiter real quick. Jupiter's probably going to be over there. Yep, I see it. Here it comes. And then what happens is with Jupiter, there are basically, Jupiter has something like 65 moons or something like that. But you can see, oh, I didn't mean to turn Jupiter off. Oh, sorry, Jupiter. You can see sort of there are 4, there it is. Wow, it's kind of going on. There are 4 moons. Oh, I see. It's because it's not in the sun. There it is. Jupiter has 4 moons that are really, really visible in a telescope, and you can sort of see them in the view here. If you like, maybe what I'll do is like just do a little doctoring. I'm going to turn the stars down a little bit so that the moons of Jupiter stand out a little bit more. There they are. You sort of see the 4 of them. They're kind of on the plane. One of those moons is actually called Europa. And I can actually fly to Europa. You've probably never done this before, so hang on and center it. Here it comes. Does anyone guess which one it is? Did you guess that one? Yeah, here we go. All of these moons are a little bit different, and that's really kind of fascinating about this. It's sort of, you sort of think they would all be sort of about the same. They're formed kind of in the same place. They're all neighboring Jupiter. Europa is special because it's got this ice crust. It's all cracked like that. We know we've got some pretty good images of Europa, and it's kind of cracked and sliced because it actually stretches and groans and sort of flattens and releases and all that stuff. So that ice sort of cracks and makes all those little fissures. Well, the next thing you're going to learn is that we are getting ready to send an instrument to be part of a discovery and a fly around of Europa. So I'm going to turn the microphone over to the team. I think Alicia is going to go next just to give us a little update on why Europa is important. And then Armand is going to show us a resource you can kind of look up about Europa yourself.
Thank you so much, Rick. All right, so we're going to go ahead and jump into our current events this week. And Rick touched on it. We're talking about Europa. And so there are three really important factors that go into whether or not a planet or a body can sustain life. And so if you're wondering why Europa, it's because scientists believe that Europa might possess those three core ingredients to sustain life on this moon or in this moon. All right, so that first ingredient is going to be water, right? Big surprise there. Everybody knows how important water is. It's essential to life, and scientists believe that Europa might actually have a salty ocean underneath its thin core. And Rick touched on this a moment ago. The reason, or I'm sorry, not its thin core, its thin shell. And Rick touched on this a minute ago. The reason why its shell is so thin is because of the gravitational pull of Jupiter. It's called tidal flexing, right? So the moon is constantly getting closer and farther away, and the surface is expanding and contracting. And doing so, it's cracking and giving us these ridges that we're seeing. Next up on our ingredient list is chemistry. Chemistry is really important because some basic ingredients sorry, my dogs are playing and it's distracting. Some basic ingredients Europa has to have in order to sustain life would be phosphorus, sulfur, nitrogen, oxygen, hydrogen, and carbon. And scientists believe that Europa might have this not only due to its formation and just the elements that are already present on the surface, but due to crater or asteroids and comets that might have left some residual elements, and as well as the rocks at the bottom of this ocean that we're talking about. So all of these could possibly lead to the elements that are needed to sustain life or give us that chemistry ingredient at least. And last but certainly not least is going to be energy. Jupiter gives off a lot of radiation, and unfortunately, things couldn't survive on the surface because of that radiation. But underneath the surface, we have what we like to call this Goldilocks zone, where the radiation from Jupiter is just warm enough to heat up the water just a little bit, the ocean a little bit, but the icy shell is still cold enough to keep it chilled so that life could possibly grow, or life could possibly be sustained in that environment. And to talk more about what's going to happen, what the future of Europa is going to be Armand. So I'm going to stop sharing screen and pass it over to him so that he can touch on the mission coming up.
Thank you, Alicia. I'm on the official mission page for the Europa Clipper mission. We can see that its launch target is October 2024. And this mission is basically going to go to Europa, to the moon of Jupiter, and search for potential signs of life. I'm going to go to this website is a really great resource, but I'm going to go to the spacecraft page where we can see a full 3D model of the spacecraft. And I'm going to talk about one instrument in particular on the spacecraft itself that ASU built. I want to remind everybody that when we're so far away from the sun, when we're all the way at Jupiter, at Europa, any heat we detect means that something's going on. Maybe not life, but definitely something interesting. And so by being able to look at how hot objects are far away from the sun, we're able to see regions where exciting things are happening. And while most of the other instruments on the Europa Clipper spacecraft are going to be looking at the subsurface chemistry of the moon, the instrument that ASU built is going to be looking at the surface itself. And the instrument is called ETMIS, and it stands for the Europa Thermal Imaging System. Yep, it's a mouthful, but it has a cool acronym. And what ETMIS is going to do is, as the Europa Clipper is going past Europa, it's going to take continuous images in strips, similar to how you would take a panorama on a phone. it's going to take continuous images in a strip, but it's going to be looking at it in infrared light so that we can find areas of warmer ice where potentially the subsurface ocean is closer to the surface. And we also know that granular or powdery surfaces, we know that they cool a lot faster than large solid blocks, regardless of the material. And so when it's in the dark, when it's facing away from the sun, the e-themis is going to look at the surface, look at the temperatures, and measure the rate at which the surface cools down so that we know more about the texture of the surface itself. Because hopefully in the near future, when we send future missions to Europa, we want to know what the surface is like if we send a lander, or potentially something to go below, because we don't want it to sink if there's snow-like material, and we don't want the surface to be so hard that we can't drill through. So yeah, by using the e-themis instrument, the Europa Clipper will know a lot more about the surface and know a lot more about potential life on Europa, and also be able to help us a lot more in potential future missions to Europa itself. And before I leave, I just want to remind everyone that even though we like to look to the stars and see fascinating things in the night sky, some of the most fascinating and interesting places are actually right here in our own solar system. So keep an eye out for the Europa Clipper mission. Hopefully it launches in a couple of years, and that's another exciting thing to be excited about, I guess.
Excellent. Armand, well stated. That's great. Yes, there's a lot of things in our own neighborhood, right? Our own solar system that we still have to explore and are fascinating. And that instrument that you saw on the top of that machine, or that spacecraft, that's very familiar to us, because that instrument was actually built at ASU, right? And when you come visit us, you can actually sort of see that instrument is now gone, but they're working on other things, and you can see sort of our instrument lab and where we build things that are going to get, kind of put onto spacecraft and launched into space and help us discover the solar system. Excellent. Thank you, Armand. Thank you very much. Appreciate it. I want to just bring Kim on real quick. Can you give us an update on Florida and what you did and what's going on? And I'm running a little bit out of time. So why'd you go to Florida? And
why did I go to Florida? Well, because I was going to go see the Artemis launch, and I'll share my screen. So a couple weeks ago when I called you, remember?
Yes,
I said, hey,
you
what
were
are you doing?
You were on the show from Florida 2 Wednesdays ago, right? That was where you were.
Yeah. So I called you, and I called everybody on the team. And so I was out at Kennedy Space Center. So driving by this is the vehicle assembly building. This is Craig Hargrove driving, and we were like, okay, let's go see if we can go see the rocket. So we did. And so LunaMap is stacked right up in there in the Orion capsule. So this was the day before the launch, and you can see like we were super excited about being there.
I love this picture of Craig. I hope he doesn't.
Yeah, and then when I called everybody on the team, this was the image that you guys got to see, because I had my camera flipped around to that. So yeah,
he's pointing right at his little instrument up there. Look at that.
Yep. Yep. So yeah, so unfortunately there's a leak there's a hydrogen leak, so they're fixing it right now. And I hope that tomorrow we'll get an idea of when it will attempt to launch again. But just to give you an idea of where I was at. So when I called you, this is the building where I was located, which is right under here, because that's the vehicle assembly building, and that's launch pad 39B. So
I get this map before. That actually puts it all into context. That's good. Thanks for sharing that.
So when I was out there, I was there on behalf of the LUMAP team as their media relations person. And so it was kind of interesting to be sitting there with like the press corps and then, having it get scrubbed and then, having to wait and experience all that. So it's kind of exciting and kind of a bummer all at the same time, just because of all the energy that, of everybody sitting there waiting. But it was kind of a highlight. It was kind of fun to call you guys and FaceTime you guys.
No, I love it. Absolutely. It was fun. And it's fun to just have you there. It's fun to have you back too. So, but
yeah, so I'm back and hopefully I can give an update in a couple of weeks about, what we're going to be doing and when it will launch again. But so right now they're just repairing it, and there'll be a press conference tomorrow with an update for the next launch attempt. So
good. Oh, I didn't know there's a press conference tomorrow. So we might hear.
Yeah, so we might hear. But so it was a good experience, and it was fun to be out there with Craig, but it was also a lot of work, and I'm glad to be home.
Well, good to have you back. So it didn't get launched, but it will. All right. Well, thank you very much. And so I just really have time just to wrap up here. And so let me do that. And this is sort of an image that I took from my backyard just a little bit ago. I had no idea. So this is a new camera that we have at school. And I hooked it up to a telescope. I have it here at home, and that's your moon. And that's what it looked like 2 nights ago. I guess this was Labor Day evening that I was out there fighting off the mosquitoes and taking a picture. The reason to bring this up is in 2 weeks we're having, we're going to just dedicate a part of the show to why are we going back to the moon? There are so many missions. At the one you just saw, that rocket is headed to the moon. But there's all kinds of other experiments. There's all kinds of things going on. It just seems to be there's this huge surge of activity. Why the moon? Why now? Why are we going back? And so we'll have some members of the Lunar Reconnaissance Orbiter team join us. And then that thing I keep alluding to is on August the 15th, we have an open house at our building in our school, and it's called Earth and Space Exploration Day. And it will be from 10 until 2. So there's a 4-hour slot. And everybody in that poll that says they've never been to our building before, I'm expecting you all to sort of like get here somehow. So please come see us. We'd love to see your faces. We'd love to hear from people that watch the show. We'd love to have some personal FaceTime with you. You'll see some of the things we do, what the Marston Theater does and how it uses its 3D technology, the gallery, and some of the projects that we're working on right now. And so just the things to look forward to 2 weeks from now. We're going back to the moon, and we're going to find out why. And then on October 15th, Earth and Space Exploration Day, right at the ASU campus, and we're going to invite everybody to come. All right, Kim, Meg, team, have I forgotten to mention anything, or are we ready to come to a close?
I think we're good.
All right, thank you, everybody.
Rick, we appreciate that date correction. Earth and Space Exploration Day, October 15th, 10 a.m. to 2 p.m. It's a great reason to join us on site. Thanks for that. And thanks to all for joining us.
Yay, thank you, Meg. All right, everybody, we'll see you next time. I really appreciate your loyalty, and I hope you had a good time tonight. I sure did. We learned a lot today. Thank you, guys. Bye-bye.